Mario once again with MIA Microflight. Today is Tuesday, August 19, 2025. I have been doing videos regarding the MIA KISS tools, which deal with primarily making your own do-it-yourself steel rule dies using some of the tools that I develop. I will get a little more detail on how to get those tools from me later on in another video. But in this video, I wanted to show you the machine that I use for die cutting using the steel rule dies. This is a machine from Accu-Cut. It's called the Mark IV. It's a machine that I got. I obtained this machine. I bought it when I think when the company started selling these. So this is an earlier machine. It's got some nice aluminum columns that support the rollers. The rollers are Delrin rollers on inside here, and you run the die underneath. Let me just grab a die here. For example, this is my own die that I developed for cutting my seats on my 1.25 size aircraft, autogyros and microlights, ultralights, and you can see it's a 3D printed part. And the steel rule is embedded inside those the channels that creates that geometry there. And so when I run a part, when I take a piece of material over that, okay, so I put a piece of plastic. This is poster board material, just a piece that I had kind of handy here, just for the purpose of this video, just to show you what it does here. Hopefully, I can get this this through here. Through. Okay, I had to get it started, but basically you just roll the handle and out comes the die cut material here. Let me bring this to the other table because it's a little dark in this area here, right here. So basically you end up with a part. Come on, baby. Okay, so you end up with a part like that. The edges here are not totally continuous here, so it's got a little gap there, and that's on purpose so that I can break away those parts as I'm doing this. Well, basically, that's the that's the seat that I manufacture for my aircraft. That I to this day I still sell the MIA 1.25 microlights and. Mainly the microlights and autogyros, hang gliders and ultralights. But basically, that would be the seat, and just a bent part die cut. This has the perforations, serrated perforations here to allow it to bend, and not it's not a through cut. These are through cuts here because they need to fold over like that with that cut. And so this is the tool that I did this tool. I did this tool using a 3D printed block here. As you see these other tools here, they have various shapes. This is for my fins that I use on the Easy 1.0 autogyro. The seat for the 1.0, it's same size, same geometry as this one here, but smaller. So we'll put that there. This is for a window for the Quicksilver style RC Ultralight. This is a cover for the Quicksilver style RC Ultralight. The pins, like I said, for the 1.0. The horizontal stabilizer for the 1.0. Some window patterns. This is the base for the Quicksilver style. The battery support base. So all these things were done with 3D printed blocks and supports here. You can see the 3D printed part. But before I started doing that, I used to buy. I used to have to do the geometry, send the geometry out to a company so they can give me a quote, so they can manufacture something like this. This isn't done in wood. This is a professional steel rule die that was done by the same company, Accu-Cut, that makes the machine. So I was getting a lot of these steel rule dies done by the company. and you know, something like this would run anywhere from $200 on up. I think I paid for this one almost $400. Imagine $400 when you can 3D print your own and make your own for you know, a fraction of that cost. So that's why I went to my own dies. It was just a matter of getting the right height of the steel rule cutting material, which is you know, that blade. It's getting the right height, and the black doesn't matter because you know, as long as you have a nice 1/4 inch gap here, so this will go through the material. I'm not cutting really thick materials. I could cut even foam. I mean, it'll cut foam like this because this is done, you know, over the foam right here to get this this pushback rubbery foam material, so it pushes back the part out. This is actual real foam, real rubber. Actually, this is more springy than foam, but this works just fine. And so for the stuff that I've been doing, it's been working fine. Here's another one that is a more simpler one. This I got from another company. This was manufactured by a steel rule of Arizona, I believe, in Phoenix, Arizona, back in 1999 when I started making my Robin 280 helicopters. I went to the company, I started working with them and see if we can cut aluminum blades. And as you can see here, this is my stock left over when I used to manufacture the Robin 280. You know, I started making aluminum and then I anodized the blades. This is done in a aluminum material that has a spring to it. I did a lot of experimentation. I mean, I spent years developing these things to the point of selecting the right material. And I even had that company that I just mentioned, Steel Rule of Arizona. I worked with them to be able to cut aluminum with its steel rule die. Unfortunately, I didn't get the steel rule die for this blade because at the time I didn't think, you know, of requesting that back, but I should have because I paid for that tool. My tool was mine, and so. But I did keep that little die that for a little fin, you know, from that company. But as you can see, you know, this is the capability of steel rule die if you do it right, if you use the right materials. I mean, I had the company punch out all these things in basswood, in plastic, in ABS plastic. You can see some of the blades that I was making back then. This is a very simple blade same thing done in ABS plastic here. The thing with this is that I had to heat curve this or heat form after the die cutting on the plastic ones. But these, the same thing, you know, cut flat. And then I had a company anodize these in various colors, you know, so that I was selling those products anodized in whatever color you wanted, you know, depending on customer choice, choice of color. And after punching these out flat, I had to come back and sand the edges manually because that does leave a sharp edge on this aluminum parts. Now this is nice and smooth. It's almost like blind slat material. Somebody kind of said that at one time when they saw me making these blades. But you know, and then I had to form this. I developed a little machine that would form this to the right curvature. A lot of experimentation doing that too, because getting this material tends to spring, and until you find out that sweet spot where it performs, you know, using equipment, you know, to measure the current draw, a certain voltage, and how much lift, all that stuff. I did, you know, spend a lot of time doing that. But these are the blades that I used to manufacture as anodized aluminum using steel ruled dies or die cutting. Here's some you know, wooden blades. These can be formed also with heat, a little bit of heat and a little heat and water. You know, you can form a wood that way, almost like furniture. Sometimes done with, you know, with heat, steam. I meant not water, but steam. Here's some other blades that I was making. Same shape blades, you know, for my Robin 280. Some other parts that I had also the same thing, steel ruled stamp, motor brackets. You know, steel ruled die. Motor brackets, and I was making, you know, my aluminum tubes, you know, for the booms of the helicopter. Here's some other parts. This is how these blades would come out. Here you can see the raw material here, and they did have a backing. You know, the company that was punching these, they used this backing here. This is just a kind of a plastic, not plastic, but some kind of a very thin waxed paper to cut these blades, but this is what I would end up with, a blade like that, and then I had to come back and sand like the edges. That was time consuming. That was the only thing. And of course, being aluminum, these blades, if they hit something hard, they're going to bend, but it wasn't. It could be bent back. It was a way for me to manufacture these things inexpensively, because injection molding something like this was going to run me in the tens of thousands of dollars to do a mold this way and have it manufactured that way. Not parts don't cost so much in plastic injection molding, but it's the tooling, that costs. And so this was a way for me to bypass that at a fraction of the cost. And as you can see how beautiful these blades are, very unique stuff that I was doing. Some of the gears that I was manufacturing, also having produced very thin blades, because at that time we didn't have the lithium polymer cells, brushless motors. I had to motors were heavy and batteries were heavy, so I had to cut down a lot of the weight and the actual architecture of the helicopter. So just to give you an idea of the stuff that as far as die cutting. And as I was saying, I should have asked for the other tools, from the other company. But unfortunately, I only got this one back, for the little fin of the Robin 280. And they were making, it's very similar to this company here. This is from Accu-Cut directly. You can tell by the difference in wood and just the rubber material that they were using here. Very professional tools, but these are $200, $400, dies here, and now I make my own here. So just wanted to capture that on this video. Now, some of you may remember, the canopies that I used to make, for the micro helicopters. I don't know, maybe 20 some years ago. And so this is how I used to also do these cuts here, these specialized cuts, to get this cleaned up. Once I formed the part, I would take it and put it on a jig to hold the canopy, and then I would use just a 2-time press to attach with the particular die on top of underneath the shaft. So when I would press that, it would cut the do this type of cutting, from the top. And I also developed one, to do the sides of the canopy, kind of like that. So I had to make another jig, to do this here. Now I eventually ended up programming my CNC machines to do all these cuts, also on a jig that was developed for the CNC machine to do this type of work.